Hey guys, welcome to another video. We are talking today about similarity once again, but we are looking particularly today at similar triangles. And in the same way that we did with congruence, we're going to look at the different types of tests we can make to show that two triangles are similar. Now, what did we discuss before in terms of similar figures? Well, we said that for things to be similar, particularly shapes, they have to have, well, I've done that too big. They have to have all their angles similar. So, for example, the different corresponding angles should be equal. Because remember, the proportions and how it looks generally is preserved. It's just made bigger or smaller when we look at similarity. And all of the sides have to have some kind of scale factor that's applied to each. So for example, if we have these lengths here, first of all, I have all the matching angles equal. 1, 2, 3, 4, and 5, 6. So all of my matching angles are equal. So let me actually write that down. So two triangles are similar. If the matching angles are equal. Whoops. Angles are equal. And if the matching sides are in proportion. So matching sides in proportion. So in other words, enlarged by same scale factor. We talked about this extensively in the previous video. So let's just check if these two triangles are similar. Well, we already know they're going to be similar because their angles are the same, but let's just check if all the sides are in proportion to one another. Well, if we consider this side 2 here, the 4 is 2 times more than that. The 3 here, the corresponding side on the bigger triangle, 6 is 2 times more than 3. And the side 8 and 4, these corresponding sides are also have the same scale factor because 8 is 2 times more than 4. So getting from this one to this one, we have a scale factor of 2. It has been multiplied 2 times. All of the sides have been multiplied by 2 to give me a bigger triangle, but it's proportionally still the same. Now, like congruence, we have a lot of tests for similar triangles, which we're going to talk about now. So, tests for similar triangles. Well, one of them is similar to, well, a lot of these are similar to congruence, but we don't want to confuse the two of them here. The first test is if 3 sides are proportional with one triangle and another triangle, then the triangles are similar. So if 3 sides are proportional. So up here was an example. We had 1, 2, 3 sides that were all proportional here. So that is a test to see if they're proportional. So if you get 2 triangles with all sides given, we need the same scale factor for each corresponding side from one to the other. So we looked at this example before. Let's take number 2 here. So if two sides are proportional and the included angle is equal. Remember, the included angle, we talked about this with congruence, is the angle in between those two sides we're looking at. Then we have another example of similarity. So for example, we have the two sides are proportional and the included angle is equal. So this is kind of like similar to the side angle side from congruence, but we're looking at different things here. So the tests for similarity go a little bit differently for the congruence we did before. So just to show you how we can check for this, we'll talk about proofs a little bit later as well. But here I can see the included angle is equal, and if I look at the corresponding sides, so this side to this side, 22 here, now you can write it out working out with your scale factor as well. So the scale factor is going to be the image over the original. So 22 divided by 11 gives me 2, and 10 divided by 5 gives me 2. So I have enough to say, because I have two sides in proportion and the included angle, that these two triangles are similar. So, test 3. If two angles are equal from one triangle to the other, to another, so if corresponding angles are equal, then we have similarity. So this is the angle one I was talking about before. Now, why only 2? Well, let's go up here. If I know that 2 of my angles are the same, let's clear this up. So if I knew, for example, that this angle corresponds to this angle and they're equal, and this angle corresponds to this one and they are equal, the third one must be equal, because the angles of triangles all add up to 180 degrees. So these must be equal as well. So it's kind of just making it easier for us, because we only need to locate 2, because we already know the third's going to be equal because of the property that all triangles have, that their angles add up to 180 degrees. So the fourth, and this is similar to one of the ones from our previous videos on congruence. This is, let me draw this down because I have to write the wording. This is that if the hypotenuse and second side, so just any other side of the triangle, of a right angled triangle are equal to corresponding sides of another triangle, they are similar. So this is kind of similar to the RHS a little bit. All of these you can kind of map to what we've learnt from congruence, but we just treat them slightly differently. Now, for example, if you have 2, 6, 5, 15 here, as long as we have two right-angled triangles and these are in proportion, then we know that they're going to be similar. Now, why do we only need two? Well, if we know two sides, we are going to know the third one as well. The third one is in proportion because all right-angled triangles follow Pythagoras' theorem. So knowing just two sides is enough to tell us about the third side. So we have that these are right-angled triangles. Let's just check the scale factor. Well, the image size for this one is 6 divided by 2 gives me 3. And 15 divided by 5 gives me 3 as well. So these are the proofs or the tests we have for checking if two triangles are similar. Now, let's just look at one big example here. It's going to be a multi-part example just to test all of the theory that we've learned so far. So if we draw these triangles here, and I have, sorry guys, it's going to take me a bit to write this out, E, A, D, B, C, and I have lengths of, is parallel, 3 centimeters, 2 centimeters, I have 5 centimeters, and X centimeters. I want to explain why the two triangles are similar. So, what are the two triangles we have here? Well, we have this one and this one up here. So, I'm looking at two separate triangles. Now, if it helps you guys, you can write these as two separate triangles if you want. You can have your bigger one here. So that's going to be your EAC. C. And you can have your smaller one, DBC. DBC. And we are going to first explain why the two triangles are similar. So we're going to start thinking about a proof. Now, we don't have to be as rigorous as with congruence because we're doing a lot more maths in terms of finding scale factors, but we still need 3 pieces of information. So let me put in my measurements here. I have 3 centimeters, 2 centimeters, X centimeters, and 5 centimeters. Well, okay. So in these two triangles, I have a pair of parallel lines. Now I'm going to be working from both this image and this one here, because it's going to help me a little bit later. Now these two lines are parallel. So what does that tell us about some of these angles? Well, when we have parallel lines and we have a transversal cutting them, if we remember, some angle relationships come about. You may recall that this angle and this angle should be the same. Why? Because remember when we have this type of F shape here, the angles within contained here and here are going to be equal. These are what we call corresponding angles. But also, this angle here and this angle here are also equal because of that same reason. These are also corresponding angles. So, oops. So for my working out in part A, I'm going to say, let's do that in black. So my side AE is parallel to my side BD. That's given here. So AE is parallel to BD. And I have my angle EAC is equal to angle DBC. So I'm going to say, therefore, angle EAC, like we said before, is equal to angle DBC. And these are corresponding angles in parallel lines. Now we can say, because we use the same idea to prove that AEC is equal to BDC, so that these two are equal. So we use that same thing. So we can say similarly, angle AEC is equal to angle BDC, and that is for the same reason. So I'm just going to put these quote marks. So therefore, the triangles contain two pairs of matching angles. And that is all we need. We just need two matching angles. Now, you also could have seen that angle C is the same in both of those. So we could have also said that angle C is common. Some of you may find that easier. You can do that as well as one of your proofs. But as long as we have two angles, two matching pairs of angles that are equal, we can say, therefore, the triangles are similar. Fantastic. Okay, now that we know they're similar, we can do part B, which is to find the value of x. Now, I know these are similar, so that means that the scale factor between this line and this line is the same as the scale factor between this line and this line. So, my scale factor, I have two matching or corresponding sides here that I have measurements for, this 3 and this 2. So I can say that the scale factor equals 3 over 2, which equals 1.5. And I can use the scale factor now to find the size of x here. So that means that my scale factor is going to be equal to the ratio of x to 5, or the fraction of x over 5. So I can say, therefore, my 1.5 equals to my x over 5. And now it's just a matter of solving the equation. So I have 1.5 here, I have 5 centimeters. So I'm going to just try to solve this equation by multiplying by 5 to both sides to undo the x dividing by 5 here. And then I get 5 times 1.5 gives me 7.5 centimeters. And that equals to x over here. So my length here must be 7.5 centimeters. And I've already proved they're similar, so that already tells me that all of these sides will have the same scale factor from one to the other. These matching corresponding sides all have the same scale factor. They are all in proportion. But that is how we can work through testing for similarity, particularly with similar triangles. It's similar to congruence, but a little bit different. But we're going to structure our proofs roughly in the same way, but we can be a little bit less rigorous with similarity as long as we still provide 3 examples. In a lot of the textbooks, they don't really go through in as much detail with the proof writing because you're doing a lot more maths in terms of calculating different scale factors and things like that. But thank you so much for watching, and I'll see you in the next video.